So, where were we? Okay, so in this math, right? Okay. So now tell me, what do you think? What is your idea about solving this math? Let me take a screenshot of this, first of all. Um, okay. A car is running at 40 kilometers per hour towards east. Okay. Can you hear me? First of all.
Yes.
Okay, good. So in this direction. The driver of the car sees a truck running at 40 kilometers per hour towards north. That means it goes from south to north, you could say. So in this direction, you could say as well. Okay. So this is a 40 root 3. 40 root 3 kilometers per hour. In which direction really the truck is running and what is the actual velocity of the truck? Okay. All right. So now you have to obviously calculate the resultant vector. Okay. So obviously the answer is pretty easy, pretty simple. Just a second. Let me. I think I have drawn something wrong. It goes to the north and it goes to the. They're going to the east. Okay, no, it's actually okay. All right. Okay. All right. So it goes to the north and it goes to the east. Okay. Now the 40 root 3 is not the actual velocity of the truck. It is what the car driver feels like. Okay. It's the relative velocity of the truck with respect to the car driver. It's the relative velocity of the truck driver with respect to car. Okay. So now, say for instance, if we calculate, say, if we replace this vector and take it here, okay, 40 kilometers per hour, and then join it perhaps, or you might not even need to do that. It's not necessary. You can easily cancel it out. Okay, say the resultant vector in this direction, you could do it with that as well. Okay, so then what will happen is r will equal to square root of 40 square plus 40 root 3 squared plus 2 times 40 times 40 root 3. Okay, so tell me, let me know what is the value for that. This is okay, so there is a cosine 90 as well. So it will be 80 kilometers per hour. Okay, 80 kilometers per hour. Okay, this is cosine 90. Are you understanding what I'm doing?
Um, Not so much on the sine 90.
Okay, so if I explain this to you, see, as you have not read about I mean relative velocity at all. So see, if I in the simplest sense, if I tell you what is going on, that is the car is moving in this direction. Okay, the car is moving in this direction, and it feels for the car that the truck is moving in the northwards direction. Okay, it is felt for the car driver that the truck is moving in the north direction. However, if he's at a very fast speed, it is not possible. Say for instance, consider that you are moving in a train. You are moving in a train with 20 kilometers per hour velocity. Just, I mean, hypothetical values. And if another train comes in this direction at 20 kilometers per hour, you will feel like that train moved 40 kilometers per hour in the opposite direction. Understand my point? Hmm. Okay. So that is what is happening here as well. So the relative velocity of the truck with respect to the car is 40 root 3 kilometers per hour. That is the relative velocity. Okay. All right. Understand my point? So now,
Yes.
when we get the resultant vector, that will be the actual velocity of the truck. Okay. Why I'm getting back into that? Okay. But do you understand the concept of like the relative velocity for the time being? That is with relation
Yes.
to a particular object, we consider a particular velocity. The actual velocity of the truck is not that. Okay. The actual velocity is 80 kilometers per hour. Okay. But it seems to the observer or the car driver that it is 40 root 3 kilometers per hour. Okay. And what will be the direction? You can easily calculate it. Say consider it theta. Then it will be 10 theta equals to, tell me what will be in the this bottom left corner. It will be
Um, 40 root 3.
40 root 3. You have made a mistake here. Okay. It will be 40. Okay. All right.
No.
So it will be 40 root 3 sine 90 divided by 40 root 3 cosine 90. Obviously, cosine 90 is 0. Okay. So then what will be the value we will get? Let me check. It will be 30 degrees. Okay. 30 degrees with respect to this. And I think you should get 60 degrees. Please calculate. Hmm. Yes. Okay. 60 degrees. Okay. Theta will be equal to 60 degrees. Okay. So are you done up until now?
Yes.
Okay. Now, see, suppose the truck is moving in the east. Okay, so the truck is moving in the, it will be a car. Okay, it's not the truck. Car is moving in the east, making an angle uh, theta with the north. What? Truck is moving in the east. Okay, I think they have made a mistake here. Okay, like the truck is moving in the north. It will be north. Okay, making an angle theta with the north. Okay. Now, also the car is moving in the obviously east direction. So what they've done is they have replaced this vector here. Okay, they replaced this vector here, and the vt vector, which is the actual velocity of the car truck, is the resultant vector. Okay. Now afterwards, we did, we calculated the resultant vector, which is supposed to be the actual velocity of the truck, and then we calculated the resultant. The direction of the velocity. Okay. Okay, so now I know there are some things which are blurry to you because you don't have the idea of the relative velocity up until now. So we will discuss relative velocity in detail in the next day. Then you will have the clear idea of that. Okay. But for the timing, just know like this bit. Okay. Or, all right. Now a man, while running at velocity 4 meters per second, comes across rain falling vertically with velocity 6 meters per second. At what angle he will have to hold an umbrella to protect himself from rain? This is actually a very important math. Okay. So see, rain is falling obviously vertically downwards. Okay. They are not saying that there is any angle. Okay. So the, if I draw the picture again, so this is say 4 meters per second, rain's velocity vertically falling, and the man is moving with a velocity of 6 meters per second. Okay, falling water running at a velocity. Sorry. The rain is falling at 6 meters per second. Okay, this is 6 meters per second. And man is running at 4 meters per second to the, in which direction? Okay, say in this direction. Okay, in this direction, that is 4 meters per second. Now, obviously, what you would understand is that whenever you will get with a very fast speed, it will feel like that the rain is like going in this direction. Okay, understand my point? Okay,
Yes.
so whenever you are taking the umbrella like vertically, so then there is a chance for like you to get wet. Okay, so then what you have to do here is hold the umbrella with some sort of angle. Okay, what is the angle? The angle would be gotten by calculating the angle. Say for instance, you have to hold the umbrella in this direction, which makes an angle of theta with respect to the man. Okay, all right. So now tell me, tan theta equals to what will be here in the bottom left corner? Tell me.
6
No, again you are making a mistake. It's 4.
is
Okay,
4.
4. Okay, and then here we have 6 sine alpha, which is sine 90 degrees, and then it is cosine 90 degrees. Okay, so then we will get tan theta equals to um, 6 upon 4. Okay, sorry. 4, that is what I'm thinking. Okay, 4 plus 6 cos 90. All right, tan theta equals to 6 upon 4. Then you will get the value for theta to be tan inverse of 6 upon 4. Right? Okay, so this is how you have to hold the umbrella. Now, the question here is that again, it involves somewhat of concept of relative velocity, okay, which we will discuss in the next again. All right, but for the timing, do you understand? Like, visualize the thing. You are like running in the rain, and you are holding the umbrella in the like vertical upwards direction. I mean, you will obviously 100% time get wet. But if you like do some angle, then there is high chance that you won't get wet. Okay. All right. So is it clear? Is this math clear? Like in
Yeah.
math, not the relative velocity portion. Yes, go ahead. You can ask questions.
Um, 6 upon 4 is 0.98 degrees.
What?
Oh, tan theta, like
Yes.
tan inverse of 6 upon 4 is 0.98 degrees.
I'm telling you. Okay, let me check. Tan inverse 6 upon 4. Uh, they have written. Okay, let me. I have 56.31 degrees. Okay.
What?
I think I'm in a mistake. I think you have converted your uh like unit to radian. Okay.
Oh, okay. Hold up.
56.31 degrees. Okay. I think it's radian.
Then I'll see what's going on. Sorry about that.
Okay, correct. Okay. Now, what was your question?
No, it's good. I'm
All
good.
right. All right. Okay. Now, maximum and minimum value of the resultant. Okay. So obviously, you know what will be the maximum value of the resultant if both the vectors work in the same direction with 0 degree, then you will get the maximum value of the resultant, which is P plus Q, right?
Yes.
And if they work in the opposite direction, you will get the minimum value of the resultant, which is P minus Q, right?
Yes.
Is that correct? All right. So now, when two vectors act along the same line, okay, so these are like, we have already discussed them. Okay. Vectors addition and subtraction in terms of components. All right. Mm, now, already I've discussed them. I think if I dive into this now, it might take some time. Okay, let me like explain it with this example. Okay, explain it with this example. All right, that will be more easier for you. Sorry. Okay. All right. See, this is the car. Okay, this is the car moving in an inclined plane. This is the car moving in an inclined plane. Okay. So now, obviously, you understand that it has a mass. Sorry, I mean weight, which is mg, right? Mass times gravity, that is the weight. All right. Understand my point?
Yes.
Now, this is the angle theta, the angle of inclination, the angle of inclination. Okay. All right. So now what we have to do is divide it into components. How can we do it? Okay. There are several ways to do that. First of all, you have to understand, I mean, in which direction you need to divide into components. Obviously, vertically, you understand that the exact weight is occurring. So what you have to do is say in this direction, there is like the horizontal component working. Why? Like, think about it. If I rotate this theta degrees, this platform to theta degrees, it will look something like, so this is, I have rotated somewhat. Okay. Like this, right? Understand my point? Then everything, the whole system gets rotated. Okay. Now consider this to be our x-axis for the time being. Consider this to be the x-axis. Okay. Understand my
Okay.
point? Because this is the plane on which the car is running or car is moving. Okay. So that is why consider the x-axis. Now, exactly perpendicular to that will be our y-axis. That is this one. Right?
Yes.
Understand my point? Okay. Now,
Yeah.
very easy. You are taking the components of the force mg or the weight. Right? That is it. Okay. So now you have to calculate like what is the angle for say for instance in this direction. Okay. So what is the angle between mg and x-axis? Tell me. Or this axis
Theta.
actually. Theta, right? Okay. So this will be no, not theta. Why are you saying theta? Not theta. Mg and x-axis. See, mg and x-axis. Okay. Isn't this the angle or between mg and x-axis? Understand my
Oh.
point? This is the x-axis and this is mg. See all the arrows.
Yeah.
So this is 90 minus theta, right? Why is it 90 minus theta? You might ask, Bhaiya. So this is 90 degrees. This is theta and this is the right angle triangle. So this will be 90 minus theta, right? Because altogether,
Yes.
I mean, total summation of all the angles in a triangle will be 180 degrees, right? Understand
Yes.
my point? Okay.
Yes.
All right, so tell me now what will be the component in this direction? That is the horizontal component.
Um,
You have all
mg cosine
cosine
90 minus theta.
90. Very good. And what will be this vertical component here?
Mg sine 90 minus theta.
Excellent, excellent. Okay. Now, I don't know if you have read about this, that cosine 90 minus theta equals to sine theta, right? I think you have read this. Okay.
Yes.
So we can transform this to mg sine theta. And also, sine of 90 minus theta equals to cosine theta. So this equals to mg cosine theta. Is it clear?
Yes.
So in this way, you will get various scenarios and various frames where you have to calculate the, components, or like divide it into the whole system into components for your easiness. Okay, say for instance the question setter might have said that, okay, the horizontal component of the weight is given as, say for instance, 75 newton. So that means you have got the value for mg sine theta, you don't have mg. Okay, so then you will need to use this equation. Then they might say, okay, so the weight is say for instance 75 newton, so then tell me what is the angle of inclination. Understand my point? So these are the questions. You will get questions related to friction even. Okay, so in the very beginning these might seem very difficult, but you have to get used to this, right? And I understand that you have some I mean, I understand, I'm pretty much sure that you have some confusion regarding what is relative velocity and the math regarding the umbrella and the track. I will discuss it to you about it next week. All right. But without that, those two maths, do you have any confusion regarding today's concepts? Please let me know that.
No.
Okay. But obviously, I mean, what can I say? Obviously, tell me about the relative velocity concept the next day. Okay. It will take a bit of time, so we will need some time to like cover it up. Okay. Understand?
Yes.
Okay. And when can we meet next? Monday at
One day
12 or
we
4.
can
Are you
meet.
free?
Yes.
Okay. All right. Allah Hafiz for today. Thank you for getting up
Allah
twice
Hafiz.
in the morning.
That's all right. It's all right. I love this. See you on Monday.